In this lesson, we're going to introduce a concept that is new, but actually is old. That concept is called the second derivative, and we've actually found second derivatives before, believe it or not. To introduce this idea, we're going to tackle this motion problem. We have this position function. We're asked to find functions for its velocity and its acceleration, and we know now the rules to do these by hand. So remember, velocity is the derivative of position. Oops, I don't need to be in capital letters. And acceleration is then the derivative velocity. So we're just going to take the derivative twice. So maybe you can see where this is going already. And we can do these by hand now. So v of t is going to be the derivative of x of t. Notice we have a function within a function. We have sine squared of t. So the derivative of that is going to be 2 sine of t times the derivative of sine, which is cosine of t. So that's my first term, and that's by chain rule. And then the derivative of natural log is 1 over t. And that's my velocity. And if you're still working on these derivatives rules, make yourself a note that this is a chain rule derivative so we don't forget later when you come back. And then to do acceleration, we're going to take the derivative again, right? And here I have product rule. So for product rule, I'm going to have two functions. I have 2 sine of t. And I have cosine of t. And then the derivative of 2 sine of t is 2 cosine of t. And the derivative of cosine of t is negative sine of t. And I can just look those up in a reference if I'm unsure what they are, right? From there, my acceleration is just going to be my product rule derivative, which is going to be my first function, 2 sine of t, times the derivative of the second function, which is negative sine of t, plus the derivative of my first function, 2 cosine of t, times cosine of t, which is my second function. And then I have to do the derivative of 1 over t. And 1 over t, remember, is the same as t to the negative 1, so I can do power rule here. So I'm going to do minus times a minus 1 in front, and then to the negative 2. So that's my acceleration, and this would simplify very nicely, actually, but that's kind of outside the scope of this video. Now, do please make yourself this note. I include these for a reason, just so we get some extra practice here, that this is a product rule derivative for a of t, just so you can figure out how you solve that later. And this function a of t is a second derivative. So anytime we've been working with acceleration, we've already been using second derivatives. Okay, so it's a familiar idea. What we mean by second derivative is simply that, like, velocity is the derivative of position x prime of t, even though we often call it v. Acceleration, then, is the second derivative, x prime prime of t. So that means to get acceleration, we take the derivative twice. And notice all of our rules apply. So we use product rule here, we use chain rule here. We're using all the same rules that we already know for second derivative. So it's nothing really new other than the notation. So we have prime notation. So f of x becomes f prime of x becomes f prime prime of x. Or we have this is called Leibniz notation. We have y becomes dy dx. And you've seen this before a little bit. And dy dx, the derivative becomes, for whatever reason, d2y over dx squared. You don't need to really understand that notation. You just need to be able to recognize it and read it. Okay. The last thing we're going to do here is we're just going to tackle an example of kind of going backwards. So we're going to start with this second derivative. So remember, this is, in our new notation, x prime prime of t is acceleration. And we're going to use it to find our original function. These, remember, are called initial conditions. And this is a previous lesson that we probably still need a little bit of work on. So my first function, v of t, is going to be the integral of a of t with respect to t. And that's going to mean we're integrating sine of t is 1. Remember, this is the antiderivative now, so we're working backwards. And what that gets me here is, to get sine, I need cosine, but the derivative of cosine is negative sine. So I need to put a negative in front of here. That's the antiderivative of sine is negative cosine, and then the antiderivative of 1 is t, because the derivative now of all of this gives me sine of t plus 1. And then I add in, this is an indefinite integral, plus c. Okay? Now, this is v of t. I'm going to plug in my initial condition to solve for c. So I'm going to be like 0 equals negative cosine of 0 plus 0 plus c. And cosine of 0 is 1, so this becomes negative 1 plus c is equal to 0, and c equals 1. So that means my function v of t is equal to negative cosine of t plus 1 is my c value. So that's my first solution here for v, but we're not done, right? So we still need x of t. So x of t is going to be the integral of v of t. So we're going to do essentially the same process again, right? We're going to be like, okay, we want the integral of negative cosine of t plus t plus 1. And the integral of negative cosine now is negative sine, because the derivative of negative sine would be negative cosine. This is just a power rule one, so I add 1 to the exponent and divide by it. That gives me t squared over 2 plus t. The integral of 1 is t plus my constant. And then I'm going to go back to my initial condition. I know that when I plug in 0, I should get 1/2, and this is kind of a nice one. Because I get 1/2 is equal to sine of 0 is 0. This is 0. This is 0. So I get 0 plus c. So c is negative 1/2. And then my function x of t becomes negative sine of t plus t squared over 2 plus t. So notice there's kind of levels to this. Once I'm familiar with this idea of a second derivative, I know if I start with my second derivative here, if I give you acceleration, you can integrate twice to get back to your previous original function.